I'm going to show you how to get your velocity versus time graph for the dry ice puck going down the first ramp, which was ramp 4, I think. All right, so we've seen that if you have a speedometer and you can take video of the speedometer, you could get the speed of this puck. If it had a speedometer, you can get the speed of the puck at any given time by looking at the video of the speedometer, but there ain't no speedometer with a dry ice puck. So we're going to have to use a different technique. And the technique that we're going to use is to think about getting the slope of our position versus time graph at different points in time. Because remember, slope on a position graph is velocity. So that's what all this is about, is trying to get the slope of our velocity versus our position graph at different points in time. And this is a little technique we're going to use for that's available to us on this website. Okay, so first thing you got to do is get your data from the previous assignment, Unit 2A1, and you got to manually put it in your columns. So I'm just going to show you what I did for the first scenario, Mass A Ramp 4. So you just plug it in, just put it in. Okay, the next step, once you're done with that, is you're going to need to make a column for velocity. So you go to Insert Column to the right, and that's going to be our velocity column. That's not how you spell velocity. That's how you spell velocity. The units are going to be, everything was in centimeters and seconds, so the units are going to be centimeters per second. And the variable, which we're not going to need, but it would be v. Okay, now we need to get data to put in here. Well, here's how we're going to do it. We're going to, there's no graph, but we're going to see that shape is like a parabola, and we're going to get the slope of the graph at different times. Okay, so let's get our graph going. So on the vertical column, we're going to pick, okay, I can't pick velocity yet because we don't have any, but position on that column and time on the horizontal axis, and we'll get our data. And you can see there's that parabola shape. Now, normally I would fit if I say, I want to fit a curve to this, I would say, okay, well, that looks like something to the x squared. Remember, these are all Mathland equations. And I click that, but that's not what we're doing here, okay? See that? But that looks so perfect. Well, that's not what we're going to accomplish. So get rid of that guy if you did it. And now we're going to do a linear. So go to where it says linear, not proportional, linear. And you're going to say, well, that's a horrible curve fit. And it is, but it's what we need. All right. So this is the weird part, but so what we want to do is we want to get the slope of this first part here. And so what we're going to do is when you click on these data points, if you look carefully, you can see they go to an X. And so that's telling the curve fit program on this website to say, don't include these points. In fact, if you get rid of all of them, you'll see that it just drops to a straight line because it has no data. Now, we want to get the curve at this first part. So what we're going to do is we're going to go back and click on the first 3 points. And then now, the line that fits to this is essentially this. I wish it couldn't keep going there, but the line is the slope at not the very first point and not the last of the 3 points, but the middle point. So the slope, that's the slope of the curve at that one point. So we can see from the graph here, it says 15 centimeters per second. Now, don't put that in for the 0 time. We need to put it into the middle of the 3. So we're going to go up and not that one. Oops. We're going to go, it's at the 0.1 second. So that was 15. Oh, I want to set up so there's one decimal place. Pardon me. I'll be right back. Going to decimals, going to 1, and done. Okay, there we go. Now, so I have so what this is telling me is that at 0.1 seconds, the velocity of our dry ice puck was 15 centimeters per second. Right? Yes. Okay, now what we do is we just kind of work our way up. So we're going to click on the first data point to remove that from consideration, and now we need to add one to the right. So now we look at the slope, 30 centimeters per second. So that is now the time that we want to use is the middle of the 3. I'm trying to get, you see how it, so basically now we're at the 0.2 seconds. The slope of our parabola at that point was 30 centimeters per second. So we're going to add that to 30 centimeters per second. Now we keep working our way up. So I'm going to click on the, there's always going to be 3. So I click on the left one to deactivate it, and then I have to go over to the right one to activate it. Now this is the slope of the middle the middle point here, and that's going to be at 0.3 seconds. So now it's 46. Okay, I'm going to pause the video and do a few more, but it works exactly the same way. Okay, so if you look at my graph, I've been working my way up the data points, and I've got through t equals 0.8 seconds, and we're nearing the end. So I'm going to go one click, just keep working up. So this, now I deactivate that one and I activate that one, and the slope is 113 centimeters per second. Wait a second. I'm going to pause because I made a mistake. Either I made a mistake or I'm doing something wrong. Okay, I'm back. I see there's a problem. So I have, actually, this is a mistake. So I'm actually going to just delete this row. Sorry about that confusion, but it made no sense. There was something wrong with that. So now I'm actually done collecting my data because this is where I was. This is my 0.8 seconds one, and if I click on delete that one, there's nothing else. So I'm actually done. So darn you, errant data point, that confused me. So, but anyway, so I got rid of it because it just makes no sense. So on yours, you're going to have the first one's going to be blank, and the second one's going to, the last one, excuse me, is going to be blank. So that's the way. So don't try to force anything into the very first at 0 seconds, and don't try to force anything in to the last one. It's just going to be blank. Okay, so now we have our data there. So now we want to turn this from a position versus time graph into a velocity versus time graph. So we're going to go up here, and we're going to change our data column selection to velocity. And, oh, so it's still deactivated. Okay, I was going to say, where's my line? I guess we're going to have to go back and activate all these points, which I didn't realize I'd have to do that. But you can see that they line up beautifully in a line. Okay, and so this is what you're supposed to fit a curve to this, and that's how you do it. So we now have a velocity versus time graph, and it's pretty darn linear. Okay, so now what do you do with that? You're going to basically look at that, and you're going to put that in your way down here. Go find the questions. Okay, so what are the equations for the best fit lines for each of the 3 graphs? That's where you're going to list them here, and then you're going to answer these questions. I hope this helps.